like every 4 hours.
No, this just for x squared.
Vertex is only a quadratic idea. But the transformations are just like the transformations to get that vertex point. So you're trying to memorize something that it's always this, but you gotta think about it.
So it's gonna be like back and forth and back and forth.
Those are only for what type of function? Quadratics.
So I'm saying
But
like,
like the transformations will always look similar to this for whatever the main operation is.
y'all can always use vertex.
It's gonna be similar to vertex form. But you gotta remember, vertex form is only a quadratic idea.
Did you want to pull up this slide 7 and we were going to do the sliders? If you wanted to, can you just move them and I'll write? Okay guys, so now let's look at your lesson 2 notes. Slide 7 is where we're looking at. Okay.
Are you lesson 2?
Okay, so looking at lesson 2 notes, looking under slide 7 where it asks you to analyze the relationship when C is at different values. So we're gonna look at this, we're gonna look at that together up here and then make sure we all have correct notes in those notes. Okay, so the first question asks when C is what? Okay, so when C is a value greater than 1. So if we move this slider, what do you notice about this transformed function?
It's stretching.
Okay, it's stretching. Where is it in relation to the parent function?
Above.
Right, so it's above and then so we also, we kind of talked about yesterday, if you look over here at line 2, are multiplications happening to what part of the function? So the multiplication right here, the C times this f of x, is on the inside or the outside of that parent function?
The outside.
Right, because it's affecting which values of the parent function. The y values, right? So when we say it's a stretch, we can also add what kind of stretch? Since the y values are changing.
One detail, so I might say, what direction is that stretch? Not, because it's a stretch, that doesn't change. So it's not a type of stretch, what direction is that stretch?
Okay, so vertical stretch. Okay, so,
Is it between 0 and 1 now?
yes. Okay, so then when we have values between 0 and 1, what do you notice about the transformed function now? Okay, it's going down, so mathematically we can say it's, right, it's being yeah, the transformation is a compression. So what happens if we're multiplying by 0? Why is it a straight line?
0.
But what, yeah, okay. Okay, so then the only other thing I would add here is we're still dealing with a vertical change in direction because it's still just multiplying these y values. Okay, so then now we can look at whenever the C, we're multiplying by something less than 0. Okay, so what happens now?
Reflection.
By just multiplying by a -1. Okay, a reflection over which axis? Okay, make sure you have something like this written down. When we multiplied the y values by a -1, my function reflected over the x-axis. Okay? Or think about it, what direction, so when we are manipulating the y values, we're changing the vertical direction. This is technically a vertical reflection.
You said right now what?
Multiplying the y values by a -1.
So don't forget you're on that question under slide 7, the last one, right?
Yeah, so guys, you're writing your notes right now under these little bullet points of that slide 7. So as we just went through, like I saw most of you writing as we were going through the different sections, so greater than 1, it was what kind of stretch? Vertical stretch, right? With our C, when we were multiplying by a number between 0 and 1, we had what kind of dilation? We had a compression. Okay? So now we're looking at when we're multiplying by a number when C is less than 0. So let me guys ask you this. When we're multiplying by a negative number, does anything change about the values for stretching and compressing? No. Right? So we can, this is just showing you guys, we can have both a dilation and a reflection in the same, like, transformation. So can someone give me an example of how, like, f of x equals x squared could be dilated and dilated and reflected at the same time? Yeah. The multiplication of what number to this would cause a dilation and a reflection? Give me a number. 2. So if I multiply by 2, that just causes a vertical stretch by 2. What am I missing to need that reflection?
A negative?
Right. So then when I have that negative, now this this x squared would be stretching and reflecting over that line. Okay, so these are other transformations we're going to be looking at, like where there's 2 and 1 function later on. All good for this one? Is there anything else you want to add?
Did you want to connect the table and the graph? Is that why this is still in there? Or do we need to go to this?
We can go to 10. Oh, 9. Okay, so now this is looking at slide 9, where we had very similar
Did they finish slide 9 and 10 yesterday?
No.
So we need to explore for a few minutes?
Yes.
What's the code? I don't need a code. I need a code.
So that's not for this.
This is the bottom one?
Yes.
What?
There you go. There's your code.
Okay, so log in, explore slides 9 and 10. But what you should be writing under the bullet points for slide 9 is very similar to what we just wrote under slide 7. But you have to make the important distinctions about, now we're looking at horizontal dilation. So what makes a horizontal different from a vertical? Okay, like really focus on writing that kind of stuff down as you're looking through slide 9.
No, you need to create an account. You need to log in so that you can access this later.
I assume you've never used this before.
Okay, so,
Oh, you
some reaction.
Oh, no, I could do that. That's my bad.
So,
Alright.
great.
Uh-huh.
So you'll need either now sign in with the Google account or put your email in.
That's not what I said.
But I don't think that's the same.
They're similar, so you can figure out how they're similar.
TCSS email yet.
Got one of them random emails on there.
So if you have a Gmail, go ahead and sign in with Google and I'll make your life easier.
Isn't .gov.com?
It should be like
Put the two instead of that.
you need to log into.
Uh,
I don't see. So there is a record.
Hit the show password so you can see it as it's typed out. So, just as absolutely need to get out, your phone in the future when you come to class and you want to get one started. But we put our phones up in the cell phone pocket over there at the beginning of class. So your cell phone pocket number will be 33. So when you come in tomorrow, just go ahead and put your phone up there starting then. But you'll need to do that.
So look where that multiplication is, line 2. So look at line 2 of where the equation is, right? So you see how she's multiplying C.
Usually I look at everybody windows and then try there.
Yes.
Well,
It's still a dilation, it's still a stretch of compression. Now it's gonna be
dilations and dilations.
But it's reflecting, like, I remember in one of the past math classes, it's reflecting meaning it's gotta go all the way. Reflecting to the other side, over the axis.
So it would have to go to the other side of the axis for square reflection.
Well, it doesn't stretch, it stretches by whatever C.
So remember, the red function is your parent function, the blue one is your transformed function.
No, seriously.
It's not reflecting, it's translation.
Talk to the group.
I don't know if you like such a
It's not a translation, first off. But the first one's wrong, it's not a translation.
Is it a dilation?
So is it stretched or compressed?
So, but, okay, so it's not one compression anymore, which is different. Yes, so the other thing we're going to do is where is the multiplication from the actual
What is this?
We have to take notes.
Okay. One other thing, I would assume most of y'all are looking at what they think first. Or looking at the fact that the blue graph is above the red one. Here, let's do this really quick. Major C2. So I would assume you're looking at the fact that the functions above the red functions is stretch, right? But I want you to look at those points again. And I want you to look at the parent function table. Are the y values different or are they the same? What the parent
Like this.
should have the parent function on the previous page. Are those y values the same or are they different? The y values are the same. So did we
Oh, yeah.
stretch or do anything to the y?
I look.
You got something in
Yeah,
there?
it's over there. Yeah, it's this. It's still equal to it. There's two.
Notice the x values change?
How many times
We don't have
have
0, 1, 4, 9, 1. So this was not vertical, it was horizontal. Equation.
Play ball, you play basketball, let them forget the basketball team.
Oh, is that kind of important? Yeah. Yeah. So what happened to your x factor to get this transformed?
Please mark this interruption. I need the following students to see your office. Sophie Smelly, Kirsten Harris, Sarah Cross, Avery Smelly, Mary Randall Smalley, Jake Bright,
Notice
and
that.
Molly Gillespie.
Yeah. Look at that 1 became 0.5. Notice how we have the same y values.
Dang, both that number, we got rolled up.
The x value of 4 became a, and that 9 became a.
What you doing right now?
They went up.
What you got? Like, yo,
2.5. Why are you so mean? You're so mean.
Man, she tried to be seen with me. She really doesn't have nobody. I know. And he
Parent
claims.
function.
Yeah.
Here's my translation.
Only song. So she was
So 0, 0.
And then, you know, from.
0,
And then vice versa.
And then 4, 5. The y values stay exactly the same, but I went from a 1 to a 0.5. I went from 4 to 2. And I went from a 9 to a 4.5. What about that half? So you could think of it as division by 2, or that's equivalent to multiplying by something. Wait, we're multiplying by x and that
Okay, wait,
right
so if
now.
it's greater than 1, it stretches.
Like, think about it.
If it's
Transfer
between, it
function.
stretches.
What is c right now?
You just like.
2. So it's square root of 2 times x, but it's actually multiplied by 1.
Like, things like that.
Why?
It increases, it decreases.
Okay, let me answer that question, I want to come back to it. If you had well, the common negative, but with transformation, what's the okay, horizontal, that's the direction.
Is that really what it is?
Well, the operation is what? Addition. So it becomes a negative. What transformation goes with addition? Transformation. What are the 3 transformations? Reflections, dilations, and
One right up.
oh, this is the first one we studied. It's lesson 1. Reflection, dilation, and translation. What does addition create? Additions and subtractions. What will create the translation? Wasn't it when you were multiplying by c and c became a negative that it would create? Yeah. So remember, that's multiplying by negative is what translates. Multiplying by or adding creates a translation. Translation by what? Okay, 4 to but it's plus. Oh, wait, when it's horizontal, it's the inverse? Okay, what's the inverse of multiplying by 2? Or multiplying by, you mean the multiplicative inverse? Oh. So So when it's horizontal, it's not gonna.
Why?
It's actually gonna.
I don't remember how to make those.
Okay, so you can do it on either
Make sure that makes sense. Let's get those notes down.
Yeah.
So remember, because here's the other thing to keep in mind. When we multiply by 2 before, we have a stretch vertically. But this is horizontal. Look at it horizontal. You see this point right here? It's now here. See how that was because it's actually multiplying by 1 horizontal. So all those points that were off to the right were used to get further to the
We're talking about.
You must be right outside your mind.
Yeah, a little bit.
Sawyer's is first day, I'll let him slide. You, sir, this is year 2 that you've had. You had me your freshman year, that's what I mean.
I know that, but I mean, like, come on.
There's no come on. Stop giving up. What are we doing here?
Oh,
What are, like, have I told y'all to back up yet?
no.
Dang.
But we have 5 minutes.
No. Yeah, we got 5 minutes to learn. We only have 2 minutes, and I still want you to learn for 2 minutes.
My learning is right here.
Yep, that's wrong.
What?
Dang.
Here's the thing I need you to consider. Wasn't this the square root of c times x? If you remember, when you look at that, it was the square root of c times x. Is that inside or outside the main operation?
Outside. Wait, inside. No, outside.
Look at that.
Inside.
That's inside, right?
Oh.
So why are we talking about vertical?
I don't know.
Like, it looks vertical, I will agree, but we gotta keep in mind, if it's inside that main operation, it's which direction?
This will be the first, right?
So, horizontal?
Horizontal.
I need a game plan.
Alright, ladies and gentlemen, I'm not gonna wrap up this task. I need y'all to stop talking. I know I'm loud enough for you to hear me. Hey, Michaela, I know I'm loud enough for you to hear me. Chicago up here. Look, we are going to come back tomorrow. We're going to continue working on this because we have got some stuff to learn. I need y'all to come prepared to discuss the math and to work the whole time, not packing up when there's 3-4 minutes left. Learning takes time. We're going to put that time in my class. All right? Is it difficult? Sure. But if you put in that time and effort, are you going to grow and learn? Yes.
It depends on how you learn, though. So.
But no, if you talk, you will be thinking and you will be learning. All right, make sure you log out of the computers. You do. You sometimes get distracted. Most days. You do talk most days. And that's okay.
More like,
Sorry, I'll be more prepared for you to come in tomorrow and we'll get you worked out.
Right on me.
Because what you're seeing is, okay, here's my parent function. You're seeing this. You're seeing a stretch. They're not seeing Does that make sense? So maybe we give them a chance, let's say 3 minutes. What transformation do you see? What transformation do you see? And we asked them about just that first question before they continue on those next 2. Does that make sense? So like very focused attention on just that question to start. Okay. I'll try to take up less time with this class than last class. That's true, but we still need to go over the question, don't we? For those 3 questions. So like, we'll still need to go through the sliders. So like, I think you did the main idea question, but you didn't do those 3 questions.
Those 3?
Yeah, with them.
Oh, that's right. I need to add that.
And don't forget to like, we can catch and release with these 2 the poll questions. You just start going with it and just let you get over it. That way we're having those discussions. Good morning, good morning. Come on, get that phone up. Good morning. Good morning. How you doing? All right. What's his name here? Let me see.
I remember it. Remember? Oh, I see it. Okay. She comes in all the time. We call it all the time. All the time. It's like I first started working with her. She's like, oh, Kiki. And she
Guys, please go ahead and have your big ideas graphic organizers out so I can collect them. Oh, got it. Yeah, this was on Friday. This is that first 20 minutes that you're supposed to work on that on Friday. You said you see right there where it has that symbol? That's not the symbol. For some reason, it's messed up. Huh?
First time in?